Hey class, we're going to finish off 8.3 with some navigation problems. We have some terminology here. So suppose there's a plane trying to travel in a certain direction. So that will be the plane's heading and airspeed. And if there was no wind involved, that would be the plane's statistics, the direction and speed. However, we have wind, direction, and speed happening, maybe something like this going in that direction. And so then the resultant of those two would be what's called the plane's true course and ground speed. Okay, due to this drift angle. So let's try an example. The key is to get these pictures drawn right so that you can find the angles geometrically and then use law of sines and cosines to solve the triangles. Here we have a plane that has an airspeed of 103 and the bearing is 77 degrees. Remember, bearing is always measured clockwise from the north. And then there's a 22 kilometer per hour wind out of the northeast. So that's towards the 225 bearing or towards southwest. And then what are the ground speed and the bearing of the plane, the true speed and course of the plane. So let's start with drawing the airspeed vector. The bearing is 77. So that's 77 degrees from the north in the clockwise direction. So let's blow this up a little bit. That's going to be something like this. There's the airspeed, where this angle in here is 77 degrees. Okay. And the magnitude of that vector is 103. Okay. And then the other vector involved is the wind vector, 22 miles per hour or kilometers per hour in this direction, bearing of 225. Let's do something like that. What happened there? Okay. So that is 22. And this angle from all the way around here, that's 225 degrees. All right. Now I'm going to draw this parallelogram with those two sides. So let's see if we can get somewhat accurate drawing here. So I'm going to finish off my parallelogram with something like this, maybe. Okay, close enough. And then the resultant vector is the diagonal of that parallelogram, which would be from there to there. There's your true course and magnitude of the plane. Okay, so now I want to try to solve, I'm going to focus on that upper triangle, right? Because I know this over here is also 22, right? And I need to find some angles inside that triangle. Okay, so in this parallelogram, what would be helpful, let's get rid of that guy. I want to find this angle from here to there, right? What is that angle? Okay, I see it in sort of a couple of ways you can do this, but if you think about that, it's three angles together. It's this angle, that angle, and that angle, all three of those added together. So that would equal, the first one here is 90 minus 77, which is 13 degrees. This one here is 90. And then over here, you have a 45-degree angle. Right? So that added together is 148 degrees. There's one way to think of it. Okay. Okay, another way to do it is just subtract the bearings, because you know that this bearing is 225, right? So I'm just, or we could do 225 minus the 77, right? That, subtract that off, that should give you this angle right there, right? So that would also be 148. Okay, so we're pretty confident that that angle is 148 in there. Okay. And if that's 148, so this angle right here is 148 degrees, then up here, that angle should be 180 using the parallelogram laws. 180 minus 148, 32 degrees. Okay, so that's that angle there. Okay. So now look what we've got. We've got side, angle, side. Okay. And I don't know what happened to my resultant vector, but I think I accidentally erased it at some point. Let's put him back in there. There, now we've got the triangle. Side, angle, side. Now I can find my vector v, the magnitude of that vector. Law of cosines. All right, so let's set up the law of cosines and away we go. The magnitude of that vector squared as each side squared minus 2 times each of those again times the cosine of that angle over there, cosine 32. All right, and by this point you're probably pretty good at calculating this, so I'll save you the pain of watching me do it. This all works out to be about 85.145 or about 85 kilometers per hour. Okay. Okay, so that is the ground speed. Sweet. How about the bearing? What is the true bearing? Okay, so in order to find that, if I go back to my picture, I need to find this little angle inside that triangle. Let's call it alpha. Right? If I could find that angle, then it's going to be easy to get the bearing, or one extra step to get the bearing, the true bearing, because the bearing is this angle to there, right? That's the bearing. That's what I want to find. Okay. So, but let's just focus on finding that little angle alpha. Right. I'm going to use law of sines for that. Okay. So, if I want to find alpha, I need to think about the side opposite that, which is the 22. So I'm going to have 22 over sine of alpha. And then do I have a pairing that's known? Well, yes, because now we know the magnitude of V and we know the angle opposite. The V is 32. So the magnitude of V is 85.145. And then the angle opposite that is 32. And there's your setup to get that little alpha. All right. So do your algebra. Your calculation is going to be sine inverse of the cross multiply. We've done this in the law of sines, divided by that 85.145. I'm using those 3 extra decimal places for accuracy. And this is about 7.9, calculating that out. Okay, so that little angle in my picture is 7.9 degrees, but the bearing, remember, the bearing is always measured from due north. So my bearing should be this entire angle, which is the 77 plus the angle I just found. So my bearing, oh, I'm just going to keep going with orange here. My bearing is 77 plus the 7.9. And that's going to be 84.9 degrees. All right. So that wind is causing the plane to go have a drift angle of 7.9, puts the bearing at 84.9. And we did it. Okay, so those are a little crazy, but if you can draw them pretty accurately and then use some geometry to get the angles, and then it's all about law of sines and law of cosines from there. All right, have fun. Send questions my way if you have any. Talk to you later. Bye.